The total force acting on an object is called the resultant force. If the resultant force is 0, then we say all the forces are balanced. Let's look at an example to explain this a bit more clearly. Here we have a car with two forces acting on it. There's the mechanical push, if you like, in the engine driving the wheels, and then there's the drag, or the air resistance, resisting that, pushing in the other direction. In this example, both forces are the same size or magnitude, and they cancel each other out. The forces are balanced. Here's another example. A box sat on a table. The force of gravity is pulling the box down, what we call its weight, and the normal reaction force from the table is pushing the box back up. Both those forces are equal in size but opposite in direction, so they cancel out, and the forces are balanced. The box stays where it is. I need to point out there's a difference in these two examples. Newton's first law tells us an object will remain at rest or in a constant state of motion unless a resultant force acts. In the example of the box is at rest. It's stationary. All the forces are balanced. In the example of the car is moving along at a constant velocity. It can only change its speed or its direction if there is a resultant force, if the forces are unbalanced. It won't slow down and stop because that would take a force, usually the force of friction, and it won't speed up. That'll take more thrust from the engine, if you like. The resultant force is the force that we get when we add all the forces acting together. Take a look at this object that's falling. It's got a weight pulling it down of 1200 newtons and an air resistance pushing it up of 800 newtons. We know the size of those forces. How do we determine the direction? Well, we've got arrows in the diagram, but if we want to do it mathematically, what we have to do is we have to say one is positive and one is negative. It doesn't matter which, as long as you're consistent with your direction. Let's just assume that going down is positive and going up is negative. So let's work out the resultant force in this case. The resultant force we get from adding all the forces together, the 1200 newtons and the 800 newtons. But the 800 newtons is negative. So it's 1200 newtons add minus 800 newtons. That bit of maths gives us 400 newtons and it's positive, so it's downwards. It's this resultant force that's acting downwards that makes the object accelerate downwards. Now, I've made a video on calculating resultant forces, so why not subscribe so you can find it easily and watch others. Can I also take a moment to suggest you visit my website, videoplatoacademy.com. On there you'll find lots of free resources, including questions and answers to go with this and every video. I also offer one-to-one lessons and group lessons, which I try and keep as affordable as possible. Here's one last example with four forces acting on it. It's an aeroplane, and the thrust is pushing it forwards, the air resistance or drag is pulling it backwards, its weight is pushing it down, and its lift from its wings is pushing it up. Now, the lift is the same size in the same magnitude as the weight pulling it down. So those two forces cancel each other out. The thrust pushing it forward is 100 newtons bigger than the drag pulling it back. So the resultant force must be 100 newtons in the forwards direction. So that plane is getting faster and faster. Now, after you've hit that like button and you've left me a comment, why not watch this?